So today we're just looking at kind of continuing the quadratic functions. We also are going to be able to graph them just by given a couple pieces of information. We're also going to practice writing the equation. So if I give you 2 points, we'll actually come up with a quadratic equation. It's going to be in a special format, so it's going to be when the b value is 0. Because normally we would need 3 points to use our quadratic progression in the calculator. We'll do this by hand actually, just using substitution a couple times. And then we're also going to look at some word problems, which you will definitely see word problems on your quiz Thursday. Alright, so the first, just a little review from last week. Remember that the axis of symmetry is the same as the vertex, because the axis of symmetry goes through the vertex. If we have our parabola here, here's my vertex. The axis of symmetry again has to go through that. And the formula for this is negative b over 2a, which needs to be memorized. The opposite of b over 2a. That's your axis of symmetry. That's also the x-coordinate of the vertex. Remember, the y-coordinate of the vertex is found by taking whatever you get and plugging it into the function. The y-intercept, remember, is always 0, c, which the c variable is the constant at the end of the quadratic. So the first 2 questions just ask us to sketch each parabola using the given information. So they've given me the vertex, so we're going to plot the vertex. We're also going to plot the y-intercept. And then remember that the point that we find at the y-intercept, we can reflect it across the axis of symmetry. Which I guess I probably should have jotted down. We're going to draw in that line of symmetry so that we can see it. And then we will just reflect it about that axis of symmetry. So we have 3, 6. And we have the y-intercept is 2. So again, I'm going to take and draw in my line of symmetry, which is going to go through the vertex. And I usually make it a dashed line so that you realize it's not actually part of the graph. It's just kind of imaginary there to help us out. And then all we have to do is reflect the point, the y-intercept across. So this is 3 spaces away. So we go another 3 spaces away on the other side. And then we'll just sketch the graph. Now this one is going to be a little bit of an estimate because we don't know if it comes straight down or if it goes out at all because they didn't give us any more points. So that will be it. So there's a little element of error in terms of like, is it getting real skinny at the bottom or is it going outward? But you would just need to have these 3 points plotted. See if you guys can try the next one on your own. Plot the vertex, the y-intercept, and sketch the graph. Again, sketch. It means it's not going to be perfect, but give us a little bit of a idea. This one should be real skinny, real tall and skinny. Okay, so plotting our vertex at -1, -4. Y-intercept is at 3, reflected across the line of symmetry, and we have a nice skinny. Over here, who could tell me, we know the domain is, just as a review since we were off for a long weekend. Domain's always negative infinity to positive infinity are all real numbers. What would the range be for this function? Well, the range is the smallest y value, comma, the largest y value. Again, focus on the y-axis. The smallest it ever touches and the largest. Ashley? Perfect. The smallest on the y-axis that the parabola ever touches is here, which occurs at -4. Comma, bracket, because it actually touches, comma, infinity, because it goes up forever and ever and ever. Okay. Go back to the other one. What would the range of this one be? The smallest the y-axis ever touches, again, think about the y-axis, And then what's the largest the y-axis ever touches? Abby? Perfect. Maybe. I found it. Smallest it ever gets is negative infinity. The largest it ever gets is a positive 6. Excellent. All right, the next two give us part of the function. So they give us the a and the b. We're just missing the c value. They want us to use the vertex that's been given to us to find out what c is. So remember, any vertex is just an ordered pair. So this is just an x value and a y value. So if we know what the x value and the y value is, we can actually plug these numbers in. Plug in the values of x and for y, and then we can solve out for c using order of operations and inverse operations. So I'm going to plug in -4 for y. When I plug in 3 for x here, I am going to use parentheses. So that would be 3 squared minus 6 times 3 plus c. And then you do need to follow your order of operations on the right-hand side. So over here, we have to use order of operations. To simplify. So we do our exponents first. So 3 squared is 9. Then we would do our multiplication next. Then we would do our subtraction, or combining like terms here. So 9 minus 18 would be -9 plus c. And then the last step would be, now we can use inverse operations to move the 9 over. We would add 9 to both sides, and what we'll get is that c is 5. And if you wanted to, you could plug that back in to get y equals x squared minus 6x plus 5. It doesn't say you have to do that, but if you wanted to on a quiz or a test, you could take this and plot it in your graphing calculator, y equals button, and double check that the vertex truly is 3, -4 to make sure that you got it correct. That's just the check. See if you guys can try number 4, find the value of c by plugging in the values of the vertex. So we should be getting c equals a -3. So just make sure that after you do perform your order of operations, which are exponents, multiplication, combined like terms, that you do use your inverse to do 0 minus 3, which is a -3. I do see the mistake. Sometimes students will put a +3 by accident. All right, the last two then on the front want us to find a quadratic function, but it's in a special form. So you have to make sure you read the directions. Notice that the b variable in this case is told to us that it's 0. Okay, so that's why they don't put it in there. That has the 2 given points. Normally, to find a quadratic, we need 3 non-collinear points, and we would go to our graphing calculator, we'd press stat, input the values, and it would calculate it for us. For this one, we have to do it by hand because we don't have 3 points. We only have 2. So we have 2 values. We have an x and a y, and we have an x and a y. So you're going to take one of those points and plug it in, and find out what the c value would be, or the a value would be. Now, to do this, you do want to pick the one that has a 0, okay, in for one of the variables, because that's going to help you to eliminate one of the other letters, a or c. So in example 6, when we get there, you're going to want to start with this one because it has a 0 to begin with. Okay, otherwise you'll kind of make the problem a lot harder in terms of substitution with multiple variables. So we will plug this value in to the equation. So that would get me 2 equals a times 0 squared plus c. Plugging in 2 for y and 0 for x. So 0 squared is 0. 0 times a is nothing. So this would just go to 0. So we're going to end up getting 2 equals c. c equals 2. Now, before you take and plug the other point in, you actually want to take the value you got for 2 and plug it in for c to get a new function. So we'll have y equals ax squared plus 2. Now we'll plug in the second point. okay? Because we've already solved for C, now we can plug in the other point and solve out for A. So we'll plug in 5 for Y, A stays A, and we'll plug in 3 for X. And then same thing, we're going to do our order of operations. 3 squared gets me 9, and I make that 9A instead of A9 just to look more normal, plus 2. And then use your inverse operation. So we'll subtract, and then we'll divide. Now make sure you don't think A is 3. A is 3/9, which would be 1/3. And it does want you to actually find a quadratic. So at the very end of this problem, you need to take the 1/3 and plug it back in for A to get your equation, which would be y equals 1/3 x squared plus 2. Didn't just ask you to solve for A and C, it actually asked you to give you the model. All right, see if you guys can try example 6. If you would like to, instead of 5/2, you can change that to 2.5 if you want, because it is not a repeating decimal. But I would, again, you want to start with this point first, because that's going to help you eliminate one variable. Okay. On the back then, we'll take a look at some word problems. Some of them are easier than others because sometimes they give you the model. Other times you'll have to write a model to come up with the equation and then also maximize that or minimize. Now all of the quadratic problems will say in some way maximum or minimum, okay? Because all of the quadratic functions look like this. So if you're maximizing, you're looking for the maximum. If you're minimizing, you're looking for the minimum. No matter what problem we do, what are we actually being asked to find? We're asking to find the maximum or the minimum. What are those points called? Abby? Yeah. So literally all you have to do for the word problems is you have to find the vertex for right now. Eventually later on in chapter 5 we're also going to talk about solving for the zeros and different models. But for right now you're just going to be asked to maximize or minimize. So you're really finding the vertex. So if you want, for all of these problems, you can use your formula for a vertex, negative b over 2a, comma blank. You also can use the graphing calculator. However, sometimes the picture won't be really easy to see or find. You might have to zoom out or zoom in. But the first question, you'll notice it says the number of weekend getaway packages a hotel can sell can be modeled by this. Negative 0.12x plus 60. Well, that's linear, right? It's a linear function. But it says where x is the price of a getaway package. And this is the number of packages they sell, is what this represents. Then they actually tell you what the revenue is, which not always will they tell you this. The revenue, so revenue is the product, okay, so product means multiplying, right? The product of the price and the number of packages sold. So x is the price, that would be x, times the number of packages sold, which is this expression, which I will put parentheses around it. What price will maximize the revenue? What is the maximum revenue? Okay. So the first thing that you would want to do is probably distribute this to make it into a quadratic function. And you might want to change revenue to be y, but you could leave it as r, just leave it as revenue, it doesn't really matter. But we would get negative 0.12x squared plus 60x. Technically plus 0 if you want to add on your c. And again, they want us to maximize. So if you think about this as just a sketch, this is a negative quadratic, so it is going to look like this. I'm looking for what price will maximize, what is the maximum. So I'm looking for the vertex. So all we have to do is find the vertex, either by hand or using the graphing calculator. So I'm going to do it by hand first, and then I will show in the graphing calculator. So if we're doing this by hand, we're just going to plug in, this is our a value, this is our b value. So I'm using the formula negative b over 2a, comma blank. Okay, remember whatever we get for the x part, we have to plug back in. So this would be negative 60 over 2 times negative 0.12. And so we would get negative 60 divided by negative 0.24. And then if you want, that is going to make the number bigger. We're going to get 250. I just didn't type in the negatives because I know 2 negatives will cancel out. But I would make sure you multiply that first. If you type this in your calculator as is, I think it'll get you the wrong answer unless you group the denominator. So you might want to do the order of operations, which would be to multiply those first. So I'm going to get 250. Now, to come up with the actual, that's the price that if we sell the package for, that will get me the maximum revenue. To find the maximum revenue, I then have to take the 250 and plug it back in for X. So we would get Y equals negative 0.12 times 250 squared plus 60 times 250. And that's why, even though I could make some of these no calculator questions, it would take you a long time to do this math off of the side. So that's why you'll get to use a calculator on Homeland. So negative 0.12, parentheses 250. You want to make sure you close the parentheses before you square it, plus 60 times 250. You can type this whole thing in exactly as you see it on your calculator screen as long as you use parentheses appropriately. We should get 7,500. Remember, that's revenue equals 7,500. Now on your quiz, it'll have 2 parts. It'll say part A, find the price that will maximize the revenue. That would be $250. And then it would say part B, what is the maximum revenue? That would be $7,500. What you don't want to do on your quiz is write those in the wrong spots, because those would be wrong. 7,500 is not the price per one package sold. It's the maximum revenue they could make per weekend. Okay. Now the next one you'll notice is harder because there's no expression written. Okay. And the way that I'll make this even harder is that I won't give you a picture in the future. We'll practice one of those tomorrow. A town is planning a playground. It wants to fence in a rectangular space. So you can see in the picture, they've drawn that for us, but in the future I might take away the picture. Using an existing wall. Okay, so they're using this wall, they don't have to put fencing there, that's just going to be closed off. What is the greatest area it can fence in using 100 feet of donated fence? So 100 feet would be like the perimeter of the 3 sides. Okay. And so you can see what they've done is they labeled this to be the length, which you could also label X. They came up with an expression to represent this because we know length, plus, in this case, width would have to be 100 because we're adding 3 sides and it has to equal 100 feet. So what they did was they actually solved for W by combining 2 L's to get 2L. And then they subtracted 2L on both sides. And that's how they got this expression to represent that length. Okay, in the future, you might have to come up with that on your own. We'll practice one of them tomorrow. But in this picture, they gave it to us. Now, we want to maximize, it says greatest. So maybe I lied, I told you it would always say maximum or minimum. Could use the word greatest or least, but same idea. Area. What's the area of a rectangle? Formula? Caleb? Length times width. All right, so you can see that in this rectangle, the length is length. The width, though, is represented with this expression. So I'm going to substitute those in. We'll have length is staying as length. Width is 100 minus 2 times the length. And you want to put parentheses to remind yourself to distribute. Then we will distribute the L to get 100L minus 2. L times L will get me L squared. And if you want to change those to X's just because the L's kind of look like 1s or are confusing to you, you're welcome to change the variables. Now before I find the maximum, you might want to rearrange this to be in standard form, because you might make the mistake of thinking this is A and this is B, but it's not. So I'm going to rearrange this to make it negative 2L squared plus 100L technically plus 0. So this would be my A value, this would be my B value, my C value would be 0. So again, I'm asked to find the greatest, and if you think about this as a shape, we want to find the greatest, we're just finding the vertex. And I'm going to use my formula, negative B over 2A. Plugging in negative 100 over 2 times A, which was negative 2. Make sure you do plug in the negative there. And we should get negative 100 divided by negative 4, which will get me a positive 25. Okay, 25 is actually what the L would be. So this would be 25. This would be 25. If they asked us for the dimensions, we could calculate the other one would be 100 minus 50, which would be 50. But the question actually asks you for the area. So 2 ways you can do it. You could calculate these first and then multiply 25 and 50. Or you can take the 25 and plug it back in here, which is what most of you would do. And evaluating that, we should get 1,250. Which is answer choice B. But if this were on a quiz, it would probably not be multiple choice. Now, really quickly, just to show you on the graphing calculator, if you were to choose to do it on the graphing calculator instead of doing it by hand, which I recommend doing it by hand, but if you were to do this, we'd have negative 2. In the calculator, you have to use x always, no matter what the variable is. So we'd have negative 2x squared plus 100x. Zoom 6. Here's the problem. I don't see a graph. Okay, and this is going to happen a lot with word problems because your answers are going to be bigger than 10. So a couple things you can do to get a better picture. You can press zoom, and you can choose 3 to zoom out. Now when you press zoom 3, it takes you back to the screen and doesn't do anything because it actually allows you to move the cursor, like if you wanted to zoom out up here or if you wanted to zoom out over here, you can actually move it. But most of the times you'll just hit enter when you get back there. And again, now I'm still not seeing anything. Let's try zoom out again. Now I'm seeing a part of it. Zoom out again. Seeing a part of it. You can see why the graphing calculator might be harder than doing it by hand. So I'm still not seeing a good picture. So sometimes you have to go back to zoom 6, restart. Some other things you can do is you can press zoom fit, which doesn't always work. But sometimes it does. It'll try to fit the screen to find where the quadratic is. So let's try that. And I can kind of see it. But this might be a better starting point for me to zoom out. So zoom 3. And what I want to do is I want to zoom out up here. We're a little short on time. But I would move my cursor up here and hit zoom out again, and it would get me my picture. The last thing I want to show, and I know I'm losing a lot of you right now, this button up here, for those of you that are graphing calculator fans, you like it. This window button, what it does is it allows you to manually change the window. So let me go back to zoom 6. All right, if I press window right now, it's going to say negative 10, positive 10. That's showing you the x minimum and the x maximum, the y minimum and the y maximum. So if you wanted to, you could change the x max to be like 100, and you could change the y max to be, I don't know, 100. And just kind of play around with it and then press the graph button. And you can see if you can see anything. So I can tell I want to see higher up. So if I go back to my window, I might change my y max to be, I don't know, 1,000. And press graph. And then you can start seeing it. It's a little more trial and error. But for those of you that like the graphing calculator, I like to show that. We will utilize that at some point this year. All right, the homework I'm passing out